Now it's time for Lassaign test. And as you know, there are 3 steps for an organic compound analysis. Right, 3 steps. First step is preliminary method, that is the solubility test. Second one is element detection, that is Lassaign test, and we're going to learn it here. And the third one is functional group test. Functional group test. From here, we will be analyzing, we'll be detecting what kind of elements are present there. Elements are means nitrogen, phosphorus, sulfur, halogen. This type of element, if present in the compound, then we'll be able to detect that in the Lassaign test. Now, to perform Lassaign test, what you have to do? You have to first make Lassaign extract. And from that Lassaign extract means a small test tube. In a test tube, there will be some liquid. It will be basically Lassaign extract. And from where you are going to make that liquid, you have given a particular compound, unknown compound. And from that unknown compound, we have to prepare Lassaign extract. Now, to prepare Lassaign extract, what you have to do? You have to add sodium. First, you have to take fusion tube. Fusion tube is basically smaller than the normal lab test tube. It's basically a small test tube and it is susceptible for high heat. Okay, so this is called fusion tube. So in fusion tube, first what you have to do, first you have to take that sample. That sample you have to take and you have to add sodium. And sodium is generally put under the kerosene because it is very much reactive. So sodium, above it is liquid kerosene and below that it will be sodium. So you have to take sodium from here and pour here. And after that, a Bunsen burner, with that Bunsen burner, you have to heat that and you have to make it red hot. That means you have to heat it very, very well unless it is red hot. And when it is red hot, the bottom portion of the sample will be red. So you have to take that. And what you have to do, you have to take one mortar and pestle. Mortar and pestle, you know, like this. And you have to take mortar and pestle and you have to break that test tube. And you have to add water and break the test tube. When you will add water, automatically the test tube will break because this is very hot. Okay. So when you will add a very little amount of water, even the test tube will break in a very robust manner. So, so in this mortar, then you have to paste well with that pestle, and you have to make the dust of the actually system. Okay. Rather than you have after that you have to purify that with a filter paper, and with a filter paper you have to collect the water here, the aqueous solution here. And aqueous solution should be a little bit basic. If the solution is not so much basic, then the test can be a little bit hampered. You can add a small amount of base here also, whatever. So this is our Lassaign extract. So this, and you will transfer in a separate test tube, and the test tube is basically this test tube. This is basically our Lassaign extract. Now you have to understand the taste for nitrogen, sulfur, halogen, and taste for nitrogen and sulfur together. Now with that Lassaign extract, or it is called sodium extract. So sodium extract, with that sodium extract, you have to add freshly prepared FeSO4. It will be provided in the lab. And you have to add HCl and you have to boil, then cool. What will happen? Prussian blue color or precipitate will appear. The color is Prussian blue. This is a very important question. In many examinations, the question comes: what is the color of Prussian blue, or what type of compound is Prussian blue color, or what is the structure of Prussian blue? What is the oxidation state of iron in Prussian blue? What is the coordination number of complex in Prussian blue? So many questions comes from there. Okay. Now, so Prussian blue color will appear. This is basically blue color. And what reactions occur here? You can watch from there. I'm not going to discuss that, but this is the actually your Prussian blue, and this is Prussian blue. This is the structure of Prussian blue, iron with coordination number 6. Okay. Sodium plus carbon plus nitrogen. What happens? NaCN is formed in this reaction. You know there is written 6 NaCN. This ferrous sulfate is going to react FeSO4 and HCl. This system is going to react here, forming FeOH whole 2 NC2, and NaCN is going to react. From where NaCN is coming? You are adding sodium to prepare Lassaign extract. So in the Lassaign extract itself, sodium is present, and organic compound means carbon will always present. So here carbon will also present. So sodium and carbon will present. But if nitrogen is present there, then we will be having sodium, carbon, and nitrogen, all these 3 in the Lassaign extract itself. So this is basically component of Lassaign extract. If nitrogen is present, sodium and carbon will always present. If nitrogen is present, then nitrogen will also be there. So overall, it will form NaCN. So in Lassaign extract, we will be having NaCN if nitrogen is present. Now for sulfur test, it's very easy. Two tests are there. If sulfur is present, nitrogen is not present. So sodium is present in the Lassaign extract, and if sulfur is present, then sodium and sulfur will combine together to form Na2S. And so sodium extract or Lassaign extract will contain Na2S. There are two tests: sodium nitroprusside test, lead acetate test. Again, a very important molecule, sodium nitroprusside. In examination of coordination chemistry itself, the question comes from sodium nitroprusside. Write the structure of sodium nitroprusside, or in which test sodium nitroprusside test is used, or what is the structure of the complex of sodium nitroprusside, or what is the oxidation state of iron in sodium nitroprusside, or what is the electron count, or what is the charge of ligand NO in sodium nitroprusside test. So these are very much important. What is the color of sodium nitroprusside? So this is deep violet. So these are very important portion for examination and for lab purpose also. And in vivas also, in lab vivas also, these questions are very much. These are very, very common things. You have to learn that. You have to understand that. You have to understand that. The second one is lead acetate test. First, what in sodium nitroprusside test, that's simple. You have to add sodium nitroprusside. With sodium extract, you have to add sodium nitroprusside. Then sodium thionitroprusside, deep violet. This it is basically sodium nitroprusside, and this is basically sodium thionitroprusside. Okay. The IUPAC name sometimes also asks sodium pentacyano nitrosonium sulfide to ferrate 2. That is the IUPAC name of that particular compound. Okay. Second one is lead acetate. You have to add lead acetate in acetic acid with sodium extract. What happens? Black precipitate appear, black PPT of lead sulfide. In this test, the very much important question, which color precipitate? Obviously black color precipitate. And what compounds precipitate? That is a lead sulfide precipitate. Okay, I know the class is getting very much boring. Okay, but it is your syllabus and you have to learn that. If it is in your syllabus, if you are doing lab, or if you want to perform your lab work with confidence, then you have to learn these things. Now halogen test is very much easy. If halogen is present in sodium extract, sodium is present. If halogen is present, then this will combine to make NaX. That means NaCl, NaBr, NaI, like this. With sodium extract, you have to add nitric acid, boil and cool, then add silver nitrate. What will happen? AgX precipitate will occur. AgCl or AgBr or AgI precipitate will occur. White PPT soluble in aqueous. What will happen? Actually, white precipitate occurs. If if chlorine is present, you will be getting white precipitate. Okay, if yellow PPT getting, that is bromine. This yellow PPT again you are getting, that is basically iodine. Now, so white PPT means chlorine, yellow PPT means bromine or iodine. You have to test with chlorine. You are confirmed with chlorine, you are confirmed, but bromine and iodine yellow. Then you have to perform the second test. You have to dissolve it in aqueous ammonia. If it is partly soluble, then bromine, and if it is insoluble, then it is iodine. Okay. Now the final, when nitrogen and sulfur both are present, if in a particular compound both nitrogen and sulfur are present, then the test is kind of different. After this test, you have to perform this test also. Okay, in this test also, what happens? If carbon, nitrogen, sulfur, carbon is itself present, it is organic compound. Sodium is present in sodium extract, and if nitrogen, sulfur both are present, that will generate NaSCN, sodium thiocyanate. And with sodium thiocyanate, you have to perform simple this test. Just read this, and finally your compound will be FeCnSCl2. It will be give blood red color. And if you get these two, this blood red color, this is very much fascinating. It looks very light, very actually it is color of blood, like of things come. Okay, so these are basically taste of carbon, sulfur, nitrogen, sulfur, halogen, and this. Okay, so these are basically Lassaign test, and Lassaign tests are very much important for element detection. So first, performing the solubility test, you have to perform Lassaign test. So after Lassaign test is complete, you have to test for functional group based on your observation in this test. If you are getting only sulfur, suppose you are getting nitrogen, so you have to perform test with nitrogen. If you are getting sulfur, then you have to uh, perform test for sulfur. That means SH, thiol. There is no actually very much test for sulfur, SH or SO3H, this kind of group with sulfur. If it is halogen present, there are no another test. Halogen present, you will confirm that chlorine is present. But in nitrogen, there are so many functional groups, isn't it? So you have to perform that. Mostly in the functional group test, mostly it will be of nitrogen, and other than phenol carboxylic acid, this will be there. So we will be discussing that in the later section. Thank you.